So hello and welcome to another video of your PYQ chapter wise series for CUET entrance. So today we'll discuss about crystallography mineralogy questions that is from 2020 to 25. So our first question is from mineralogy. Name the Mn bearing garnet. So garnet minerals are divided into two groups. One is called pyral spite. Another is your ugranite. Okay, so py it is for pyro. Okay, PYR this is for pyro. Al it is for almandine, and spit it is for spessartite. And here U for uvarovite, Gr for grossular, and andit it is for andradite. So this is also called as your aluminum series. This is called as your calcium series. So how we will remember this formula? So in case of your pyral spite group, this thing is constant, Al2Si3O12. So pyrap is Mg bearing, almandine is Fe bearing, and spessartite is Mn bearing. So this Al2Si3O12 will be constant, pyrap Mg, almandine Fe, spessartite Mn. In case of ugranite series, we have uvarovite, grossular, and andradite. Here Ca3 and this Si3O12, this is constant. So uvarovite it is chromium bearing, C3Cr2. Grossular it is aluminium, andradite it is Fe2. So among which one spessartite it contain Mn, so it will be Mn bearing. I remember if any garnet that starts with letter A, it always contain iron. So answer will be spessartite. With grossularite it is Ca3Al2, calcium aluminum bearing, pyrap Mg bearing, uvarovite chromium bearing. Then how many minerals in the Mohs scale hardness are silicates? So Mohs scale hardness has 10 minerals. They are talc, gypsum, calcite, fluorite, apatite, then orthoclase, quartz, topaz, corundum, and diamond. So among these minerals, your talc it is silicate. Gypsum it is sulfate, calcite it is carbonate, fluorite is CaF2, calcium fluorine, apatite is phosphate. So talc is your silicate, but it is hydrosilicate. Gypsum it is hydrosulfate, CaSO4.2H2O, calcite CaCO3, fluorite CaF2, apatite CA5, PO4 whole 3 OH group is there. It is also hydrous. Orthoclase, this silicate, this is silicate. Quartz, this is silicate. Topaz is silicate, also hydrous. Corundum is oxide, aluminum oxide. So diamond is your carbon. So among these silicate, there are 1, 2, 3, and 4. There are 4 number of silicate present in the Mohs scale hardness, among which talc is hydrous. I'll write down here. H4 you can say hydrous, gypsum hydrous. Then you'll get apatite hydrous, topaz hydrous. There are 4 silicate present and also 4 hydrous mineral. And phosphate is your apatite, corundum is your oxide. Sometimes question that which is the most hardest oxide in the Mohs scale hardness, that will be corundum, which is the hardest oxide, Al2O3. So here answer will be 4. Then the type of mineral of a tetragonal system normal class. So zircon is your tetragonal system, tetragonal. Barite, it is your orthorhombic. Then axinite, it is triclinic. Gypsum is your monoclinic. Then galena is your cubic or isometric, and beryl is your hexagonal. These are the normal class type. So in tetragonal system, this is zircon. So isometric system, galena type. Then your tetragonal system, zircon type. Hexagonal system, beryl type. Orthorhombic system, barite type. Monoclinic system, gypsum type. And triclinic system, axinite type. The next question, a crystal with no axis of symmetry, no plane of symmetry, and only center of symmetry is named as. So orthorhombic normal class, it has symbol 2 by m, 2 by m, 2 by m. So there are mirror planes, there are center of symmetry. Monoclinic, it has 2 by m, it has mirror plane and center of symmetry. Triclinic, it has 1 bar. So it doesn't have any mirror plane or any axis of symmetry, only have a center of symmetry, because 1 bar is equivalent to inversion I. And rhomboidal division, it is 3 bar. It also possesses a center of symmetry and axis of symmetry. So answer will be your triclinic normal class. Then comes to moscovite. Moscovite it belongs to mica group. So mica group, so seed silicate structure, or you can say phyllosilicate, which has a silicon oxygen ratio of 2:5, where each tetrahedral share 3 of its oxygen. You have double chain, which has a ratio 4:11, silicon oxygen ratio 4:11, where 2 or 3 of the oxygen will be shared. Then framework silicate is also called as tectosilicate, ratio is 1:2, where all the 4 oxygens are shared. In single chain, it belongs to your inosilicates, which ratio is 1:3, where each tetrahedra share 2 of its oxygen. Then we have nesosilicate, which has a ratio 1:4. We have sorosilicate, ratio is 2:7. Then we have cyclosilicate, ratio is also same as single chain, 1:3. So double chain, we have example amphibole. Amphibole belongs to double chain. Then framework silicate, you can take the example of quartz, you can take the example of feldspar, you can take the example of garnet. They all are framework silicate. Sorry, garnet. Garnet is not framework silicate, it is nesosilicate. You can take the example of quartz and feldspar. Single chain, you can take the example of pyroxene. Pyroxene group belongs to single chain silicate. Then nesosilicate, you can take example olivine, garnet. And in Sorosilicate, you can take the example of hemimorphite, joycite. Those are sorosilicate, where oxygen ratio 2:7, where only one oxygen shared, and it consists of two tetrahedra. 1:4, it consists of a single tetrahedra, doesn't share any of its oxygen. Then 1:3, that is cyclosilicate. They share two of its oxygen, but they occur in a cyclic manner. Take the example of your beryl, that is a cyclosilicate. So here moscovite will belong to seed silicate. So answer will be seed silicate. Then comes to transition elements are uniquely suited to act as a chromophores. So what is an chromophores? They are present very less amount in a mineral, but they controls the color of the mineral. So basically chromophores are elements like iron, chromium. Those are elements that present within the mineral. So they have partially filled d orbitals. The transition element they have partially filled d orbitals. So as they have partially filled d orbitals, they have capacity to absorb certain wavelength of light when light passes through these elements. So because of this property, they can control the absorption of the wavelength, a visual wavelength, and can control the color of the mineral. So transition elements, those have they have partially filled d orbitals, and they controls the color of the mineral. That was they called as chromophore. So answer will be A. These are not related to this chromophore condition. So answer contain electron in partially filled d orbitals. Then a zone. So what is a zone? So zone in a crystal, you can say a group of faces whose edges are parallel to each other. So you have to consider, you can say, faces. Suppose I will consider the four vertical faces. Their edges will be this one, this. All the edges will be parallel to each other. If all the edges are parallel to each other, they are considered as these four faces are in a zone. So understood, zone in a crystal is consists of group of faces whose edges are parallel to each other. Zone is basically defined by a zone axis which passes through the center of the crystal and parallel to all faces in a zone. So suppose, so this will be a zone axis. So you think of your wall of your room, all the four vertical walls, they are in a zone because all the edges you consider in your room, you can take two edges, you can take three edges or four edges, all will be parallel to each other. So if you consider another axis, that is from roof to floor, so that axis will be parallel to all faces. So that will be considered as your zone axis. So here this axis will be considered as a zone axis. So which is parallel to all faces. Now see what is the question is given. A zone in a crystal, that means if you are defining any zone, then you will define it through zone axis. So it is indicated as, so zone axis, so it is indicated by square bracket. If you can use square bracket, so it will indicate a zone axis. Then a simple bracket, it indicate a specific plane, and a curly bracket, it indicates a family of planes that are symmetrically related, and a triangular bracket, it indicates a family of directions that are symmetrically related. So here answer will be UVW square bracket. So next comes to optic axis. Optic axis is defined as the direction or directions along which. So what is an optic axis? First we'll see optic axis. So we know a phenomenon that is called as double refraction. when light enter into an anisotropic mineral, it splits into two rays. One is slow ray, one is fast ray, and they are vibrating at you can say perpendicular planes. So one ray is slower, one ray is faster. So optic axis means it is a direction within a crystal along which there will be no double refraction, or you can say light will vibrate equally in all direction. So that is called optic axis. So optic axis is defined, there is a double refraction, incorrect. There is no double refraction, this is correct. The ordinary extraordinary ray that does not produce along optic axis, it is only produced when light travel in a direction which is not optic axis. So on the basis of number of optic axis, we have two minerals, two category you can say. One is uniaxial mineral, one is biaxial mineral. So mineral having one optic axis is uniaxial, mineral having two optic axis is biaxial, and mineral having infinite number of optic axis, that is isotropic. So isotropic minerals that belongs to isometric system, they have infinite number of optic axis. But in case of uniaxial and biaxial, uniaxial has one optic axis which coincide with the C crystallography axis, and biaxial it has two optic axis, the orientation changes mineral to mineral. So uniaxial mineral that they crystallize in tetragonal hexagonal system, biaxial mineral they crystallize in orthorhombic, monoclinic and triclinic system, and isotropic mineral crystallize in isometric system. So remember these things so you can identify which one is uniaxial, which one is biaxial. So answer will be there is no double refraction. Then pyrethrohedron is the hemihedral form of. So pyrethrohedron so name comes from pyrite, it belongs to diploidal class, has a symbol of HK naught. Symbol of HK naught. So it has 12 number of faces. Okay, then hemihedral form. So hemihedral form is half the number of faces required to show the full symmetry. So that means pyrethrohedron is 12 faces. So it should be an hemihedral form of a crystal form that has 24 number of faces. So let's check which one have 24 number of faces. So that means trisoctahedron, tetrahexahedron, trapezohedron all have half the number of faces. So let's then examine the symbol. So trisoctahedron, it has a symbol of HHL. Tetrahexahedron has a symbol of HK naught. Trapezohedron, it has symbol of HHL. Also HHL. So here you can see tetrahexahedron and pyrethrohedron same symbol, and pyrethrohedron contain half number of faces than tetrahexahedron. Answer will be tetrahexahedron. Then in case of trisoctahedron, remember here H will be greater than L, and in case of trapezohedron H is less than L. Trisoctahedron has a hemihedral form, that is called as a tricetetrahedron. Tricetetrahedron, which is also a symbol HHL, but here H is less than L. So it has tricetetrahedron means it has 12 faces. It has 12 faces, which is hemihedral form of trisoctahedron. There are 24 faces. Then delta dodecahedron has 12 faces. Here H will be greater than L in case of delta dodecahedron. So these are forms. All these forms that belongs to isometric system, and all are, you can say, closed form. There is only one system, that is isometric system, which contain all the closed form, which has only closed form. Not that it contain only closed form that doesn't found in other system. It has closed form. Isometric has only closed form. Other system has both closed and open forms. Then which of the following is not a closed form? So closed form means, what is closed form? What is open form? So open form means crystal doesn't have sufficient number of faces to enclose a space, that is open form. Then closed form, if crystal have sufficient number of faces to enclose a space. Suppose you can take the example of pedion. It consists of one faces, it can never enclose a space. You can take the example of pinacoid, which consists of two faces. It can never open the never completely cover a space. So we'll see rhombohedron, which consists of 6 number of faces, rhombus shaped faces, which is a closed form. Scalenohedron, it consists of 8 or 12 number of faces, all consist of scalene triangle, it is also a closed form. Trapezohedron belongs to isometric system, that it is closed form. Then fast order prism. So fast order prism is like this, it has 4 vertical faces. It has 4 vertical faces. There is no face in top and bottom. There is no face along top and bottom. If you only take these 4 faces, they will be considered as prism. So prism is always an open form. Remember, prism is always an open form. Like prism, we have pinacoid, dome, sphenoid, pedion. Okay, only pyramid you can take. So pinacoid has 2 faces, dome has 2 faces, sphenoid has 2 faces, but dome sphenoid has non-parallel faces, pinacoid has parallel faces. So pinacoid has parallel faces, these are non-parallel faces, pedion has 1 face. Pyramid has 3, 4, 6, 8 number of faces. All the faces will intersect a common point or common axis. Then prism, it also consists of 3, 4, 6 number of faces, where all the faces must parallel to a common axis. All are open form. Pyramid is, you remember, open form, but if it is bipyramid, then it is a closed form. So answer will be fast order prism. Then mineral anorthite has. So anorthite belongs to triclinic system. It belongs to normal class of triclinic system, which is 1 bar. So that means it doesn't have any axis of symmetry. So no axis of symmetry. It has only a center of symmetry. When it comes to out of 32 crystal classes, only dash classes have center of symmetry. So always remember, if any HM symbol, if the first letter of HM symbol is 1 bar, 3 bar, then 6 by M, 4 by M, 2 by M. So if the first letter of the HM symbol is 1 bar, 3 bar, 6 by M, 4 by M, 2 by M, then they contain center of symmetry. So if it is 1 bar, 3 bar, 6 by M, 4 by M, 2 M. Remember all the normal class system, all the symmetry classes, that is 32 number of symmetry classes, among which only 11 classes have center of symmetry. Only 11 classes have center of symmetry. Then 21 classes doesn't have any center of symmetry. Which of the following crystal system has maximum crystal classes? So triclinic, we have 2 crystal classes, monoclinic has 3, hexagonal has 12, isometric has 5, tetragonal has 7, and orthorhombic has 3. So total we have 32 crystal classes, among which hexagonal contain the highest number of classes, that is 12 number of classes. So next comes to which of the following statement is true for hemihedral form. So hemihedral form, it is the half number of faces required to show the complete symmetry of a holohedral class. So we have discussed in case of hemihedral case, that is your pyrethrohedron has a hemihedral. It is a hemihedral form of tetrahexahedron, and a common example you all know, that is कि tetrahedron is a hemihedral form of octahedron, then required half the number of faces required to show the complete symmetry. So first option is given, they belong to same crystal class as the Hardness forms. They belong to same crystal system actually. But all the options you have A. Actually this will be, if you correct this, they belong to same crystal system as the holoidal forms. They belong to same crystal system, not class, because tetrahedron, octahedron are not same class, or pyrethrohedron or tetrahexahedron, they are not same class. They belong to different class, but they belong to a same crystal system. So let's take this as system, then it will be correct. Otherwise, if you write class, then it will be incorrect. They have same indices as the holoidal form that we have already discussed. In case of pyrethrohedron and tetrahexahedron, both have HK naught. In case of tetrahedron, octahedron, both have 1, 1, 1. In case of trioctahedron, tetrahedron, both have HHL. So if this is system, this is correct, then they have half number of faces as the holoidal form, this is also correct. For each holoidal form, there are corresponding 2 hedral forms, it is incorrect. So answer will be your A, B and C. But there is no such option. So it will be A, B, C. It will be A, B and C. Okay, next table match, that is mineral anthophyllite. So anthophyllite is a mineral that belongs to amphibole group. Anthophyllite, jadeite, then cumingtonite, grunerite, tremolite, actinolite, hornblende, then glaucophane, rebecite, they all belongs to amphibole group. Then pyrope, we have discussed this, it belongs to garnet group. Augite, you know, it is a clinopyroxene. Biotite belongs to mica group. So A is second, there is only one option. B 1, C 4, D third. Option B will be correct. So this thing you have to remember all the mineralogy of mineral group. Then you can easily solve this. The number of faces present in hexaoctahedron. So the name itself suggests how many number of faces. There is 6 and 8. It will be 48 number of faces. This is the highest number of faces in any form in any system or any class you can take. There is 48 number of faces, which is the symbol of HKL. So hexaoctahedron class, it belongs to, hexaoctahedron form belongs to isometric cubic class, a cubic, or you can say hexaoctahedral class. Waxier Gigi luster is executed by. So Gigi luster, it is shown by sulfur bearing minerals. Then diamond show adamantine luster, quartz show metallic luster, quartz show vitreous luster, galena show metallic luster. The answer will be sulfur. Diamond, cellucite, they also adamantine luster. Which one of the following is non-pleochroic? So always remember, in case of mica group, how we'll distinguish between biotite and moscovite. Biotite is very strongly pleochroic, but moscovite is non-pleochroic. That is a very common distinction between biotite and moscovite. Very common point. Remember this thing. So moscovite is obviously non-pleochroic. Hypasthene, it is belongs to orthopyrazine, it is pleochroic. Hornblende is pleochroic. Chloritoid is pleochroic. So answer will be moscovite. So pleochroism, it is a plane polarized property. When you rotate the stage under plane polarized condition, then the mineral will change color at different direction. If it is a basically pleochroism is shown by anisotropic mineral, that is uniaxial, biaxial. Uniaxial will show 2 change in color, biaxial will show 3 change in color. So basically uniaxial is called as dichroic and biaxial is called as pleochroic. And uniaxial will show 2 change in color, that's why they are called as dichroic. Then your non-pleochroic you'll find non-pleochroic mineral in anisotropic case, but all isotropics are always non-pleochroic. Then it comes to diaphaneity. It is a property that defines the transmission of light through a mineral, that is transparent, translucent, or opaque. So that property is called a diaphaneity, which defines the transmission of light through mineral. So answer will be transmission of light. Which of the following has the highest hardness? Among these minerals, already discussed, that is corundum. Corundum has hardness of 9, topaz has 8, calcite has 3, and siderite doesn't have that much of hardness. So answer will be corundum. Then camouflage is a type of ionic substitution that takes place in atoms having. Camouflage means if you replace something, it will not noticeable, you can say. So you cannot tell the substitution whether it is occurred or not. So camouflage always occur with two substituting atom having same radius and same valency. So answer will be this one, same radius and same valency. They are called as a camouflage, because when we have same radius and same valency, then the charge will not be disturbed, and also exactly the same size the substituting atom will occupy. So it will not produce any distortion or any defect within the crystal. So keeping the structure exactly that is before. So that is also characteristic of a substitution condition. So where same radius and same valency occur between substituting ions. So during substitution, ionic radius can be considered up to 15% size difference. If two substituting ions have a size difference in between 15%, 0 to 15%, they can be easily substitute with each other. They can show camouflage. Same valency, without same valency, there can be also substitution. If valency difference is 1, if valency difference is 1, then there will be substitution, that is called as coupled substitution. This is called a coupled substitution, which generally found in plagioclase minerals, a plagioclase group of minerals, where Na plus replaces Ca plus. So Ca, it has 2 charge, Na has 1 charge, so they cannot, if they will replace each other, there will be a charge deficient. So to balance that charge, Na plus replaces with Si4 plus and Ca2 plus replaces with 3 plus. So these two will replace these two. That's why it is called as a coupled substitution. These are occur to balance the charge. So this is same valency, same radius. It is called as a simple substitution. So answer will be A. Which of the following is an oxide of titanium and iron? So rutile, brookite, anatites, they are polymorphs. They have a composition of TiO2. So rest your ilmenite, FeTiO2, like iron and titanium. So answer will be ilmenite. Which crystal class is both hemimorphic and enantiomorphic? So what is hemimorphic? Previously we have discussed hemihedral. Now we have hemimorphic and enantiomorphic. So hemimorphic is a crystal form where there are dissimilar crystal faces at a two end of an axis. It is like this, you can say. So suppose this is an axis where you will find two faces here, but they are dissimilar faces. So this type of form is called as your hemimorphic form. This is called as your hemimorphic form. And in enantiomorphic form, they doesn't have any plane of symmetry or center of symmetry. They only have axis of symmetry. So there are 9 hemimorphic form and 11 enantiomorphic form. What are the hemimorphic form? Those are your 1, 2, 3, 4, 6, then M, 2 mm, 3 m, 4 mm, and 6 mm. So these are your, you can say, hemimorphic form. Then enantiomorphic form is your 1, 2, 3, 4, 6. Okay. Then your 2, 2, 2, 6, 2, 2, then 3, 2, then 4, 2, 2, then we have 4, 3, 2, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So now these are enantiomorphic form, these are hemimorphic form. So among these, which crystal is both hemimorphic and enantiomorphic? So gyroidal, it has a symbol of 4, 3, 2. So it only belongs to enantiomorphic form. Then pedial. Pedial is your 1. So it belongs to both hemimorphic and enantiomorphic. Pinacoidal is 1 bar. There is no such form called spheroidal. It can be sphenoidal. The sphenoid, it is not written sphenoid, it is written spheroidal. So there is no such class. So answer will be pedial, which is both hemimorphic and enantiomorphic. Which crystal system has 3 unequal axes intersecting at oblique angles? That means 3 unequal axes, they are intersecting at an unequal angle. That will be your trigonal system. A, B, C are unequal, alpha, beta, gamma is also unequal. Orthorhombic, all unequal axes but at right angle to each other. Then monoclinic has all unequal axes. Only beta angle is not equal to 90 degree, alpha, gamma may be 90 degree. Tetragonal, horizontal angles are equal. Sorry, horizontal axes are equal. Vertical axis, C axis is unequal, and they are mutually perpendicular to each other. Next question. In hornblende, cleavages intersect at an angle of, so it is 56, 124. It's a very common question. 56, 124. It is the cleavage angle of hornblende that belongs to amphibole. You know, all the mineral belongs to amphibole will show 2 sets of cleavage, an angle of 56, 124. But pyroxene show 87, 93 degree. Feldspar show at 90 degree angle. So next comes to this question, to this table match. So it is our composition. So you know quartz is SiO2, calcite is CaCO3, corundum Al2O3, diamond C. So quartz is IV. There is only one option. So answer C will be correct. Then the weakest chemical bonding. So this van der Waals bond, it is the weakest chemical bond. Where covalent and ionic, those are more stronger bond. Metallic also more stronger bond. The van der Waals bond is the most weakest chemical bond. When it comes to olivine is, so we have discussed it earlier. Olivine belongs to nesosilicate structure, ratio 1:4. Also we have discussed all these type of silicate and their examples and their silicon oxygen ratio. So here answer will be nesosilicate. Comes to which of the following is related to pleochroism phenomenon observed during petrological study using the thin section. So I have discussed about pleochroism earlier. It is a property under plane polarized light. When we'll rotate the stage under plane polarized light, the mineral will change, show change in color. So it observed on rotation of thin section under plane polarized light. So it is correct. It refers to change in hue or intensity of color during rotation. Either full color will change or intensity of the color will change. All will considered as polarized. Sorry, pleochroism. It is caused by different degree of absorption light. This is the cause of the pleochroism. Different degree of absorption light by the mineral in different orientation. Same amount of absorption, it is not a cause to show different intensity of color. So answer will be A, B and C. A, B and C. It will be B. The anisotropic crystal. So what is an anisotropic crystal? So all the crystal can be divided into two types, or minerals can be also divided into two types: isotropic and anisotropic. When light traveling through a mineral will vibrate equally in all directions, that is called as isotropic. If it will vibrate unequally, then it is called anisotropic crystal. So all the minerals that belongs to isometric system are isotropic, because isotropic mineral, they should have equal development in all directions. So any crystal system, they have all equal crystallography axes will be isotropic. So the anisotropic crystal transmit light with equal velocity in all directions. So this is the property of an isotropic mineral. Transmit light with different velocity in different directions. This will be the correct one. Has ray velocity surfaces as a sphere. So this is the characteristic of isotropic, where wave surface of isotropic mineral is sphere. Are hypothetical and never occur really in nature. This is also incorrect, because they are not hypothetical, they occur in nature. So answer will be transmit light with different velocity in different direction. Then transmitted light microscopy are mostly used for study. Transmitted microscopy we use to study thin section of rocks and minerals, where light transmit through the thin section. And reflected we use to study economic or ore mineral, that is studied by reflected microscopy. So answer will be thin section of rocks and minerals. When it comes to the general open form, 1 bar is known as. So 1 bar, it is inversion, it is called as your pinacoid. It is called as your pinacoid. Then pedian is your 1, dome, this M. Prism have different symbol depending upon types of prism, whether hexagonal or tetragonal or rhombic. So general open form of 1 bar, it is your pinacoid. It is pinacoid. When it comes to the Roto inversion axis of 6 bar, it is equivalent to 3-fold plus mirror plane. Then your 3 bar equivalent to 3 plus inversion. 4 bar is a unique operation, it does not belongs to or does not similar to other operation. Then your 1 bar equivalent to I, inversion. Then 2 bar, it is equivalent to a mirror plane. So remember these things is very important. So 6 bar means we have 3-fold plus mirror plane, that means 3-fold and perpendicular mirror planes. 3 bar means we have 3-fold with a roto inversion axis, that is an inversion. 4 bar, simple 4 bar, 1 bar inversion, 2 bar mirror plane. So let's see which option will be correct. 3-fold rotational axis of symmetry, 6-fold rotational axis of symmetry are not correct. 3-fold rotational axis of symmetry with perpendicular mirror plane. So this will be correct. So it will be written as 3 by m, which will be 6 bar. It will be 6 bar. If the axial intercept of faces are 2a 2b minus 2 by 3c. So intercept is given 2 minus 2 by 3. So Miller indices, it is the reciprocal. We will take the reciprocal 1 by 2, 3 by 2 minus 2. So it will be 113 bar. It will be 113 bar. So this might be the option 113 bar. Then comes the normal class of orthorhombic system is represented by the symbol. So orthorhombic system by the normal class of 2 by m, 2 by m, 2 by m, which is rhombic dipyramid. Then 2 is spheroidal class. Then 2m, there is no such class 2m. M is your domatic class. Then we have 4 by m, 3 bar, 2 by m. It is the normal class of isometric system. Then 2 by m, 2 by m. It is the normal class of tetragonal system. 6 by m, 2 by m, sorry, 6 by m, 3 by m, 3 by m. It is the normal class of hexagonal system. Then your 2 by m, 2 by m, 2 by m, it is normal class of orthorhombic system. Then 2 by m, it is the normal class of monoclinic system. Then 1 bar is the normal class of triclinic system. This is called as a hexaoctadal class. This is ditetragonal dipyramidal. This is dihexagonal dipyramidal. This is prism. This is pinacoidal, and this is rhombic dipyramid. Then comes to this question: which of the following system has all closed form? We have discussed this. Only your your isometric system, that is cubic system, it has 15 forms. All are closed form. Only this system contain only closed form. All other can contain both. Triclinic has only open form. Basal parting can be observed. Parting means it is a cleavage or weak planes. So basal cleavage is the characteristic of mica group. It has one set of basal cleavage. Olivine, it doesn't have any cleavage. Pyrazine has prismatic cleavage. It has prismatic cleavage, two sets, and Optical also has prismatic cleavage. That both contain two sets of cleavage. Pyrazine has 8793, Optical has 56124, called as prismatic cleavage. So basal cleavage, it is characteristic of mica. So next, when light passes through anisotropic mineral, it splits it into two beams. This phenomenon is called as your double refraction. Any anisotropic mineral, when light will enter into the anisotropic mineral, it will split into two rays. One is fast, one is slow ray, and the both ray will vibrate perpendicular to each other. So in case of uniaxial, we call them as ordinary ray, extraordinary ray. Ordinary vibrates in the basal section, extraordinary vibrates in the principal section. Come to refractive index of Canada balsam. So as we know, refractive index of Canada balsam is 1:1:54. So here this option, it is 1.537. If you round up them, it will be 1.54. This is a data question you have to remember. So next question, optic sign of Moscovite. So Moscovite, it is biaxial negative. So this thing you have to remember, the data question. So answer will be biaxial negative. So this is all your mineralogy crystallography question of CUET from 2020 to 2025.